Alright, hello class. Today is going to be a short video because it's on a topic that you have been familiar with because you've been working with these type of functions throughout your high school math career. And these functions are polynomial functions. Poly meaning many, and meal is many monomials, which is what is a new word, but actually you've been dealing with them all the time. The standard form of every single polynomial function is in this form: a sub n minus 1, a sub n minus 2, all the way up to a0, all represent coefficients or real numbers. And x to the n represents the variable raised to a power. So a sub n minus 1, all the way up, they're real numbers, and the only requirement is that n is a non-negative integer, which means it could be 0, 1, 2, 3, 4, 5, all the way up to 100 million. It has no decimals and it has no fractions. Now, the highest power of the polynomial is called the degree, and the degree is the largest power integer. Okay, so I'm going to give you some examples if that's confusing to you. But before we look at the examples, I want to explain about why polynomials are so important. Number one, they're continuous, which means they don't have breaks, so you don't have to worry about any holes or gaps. And then they're smooth, which means they don't have any sharp edges. And so as a result, their domain is all real numbers. You can input any number, real number, into a polynomial function and you will always get out an answer. Now, some popular polynomials that you've been working with are constant functions. F of x is equal to 3. If you remember that, the graph of that is just a horizontal line wherever the polynomial, wherever the constant is. And the leading coefficient is always the highest power, but we'll talk about that later. The next popular polynomial function are linear functions. Linear functions are polynomial functions, but their highest power is degree 1. So once you linear functions are just polynomials of degree 1. And so as you can see here, they both have two coefficients. A1 represents the slope, which you're familiar with, and in this format, A0 or A0 represents the y-intercept. Another popular polynomial that you guys are familiar with is the quadratic functions. Quadratic functions have a highest power of 2, so their degree is 2. Linear functions have a highest power of 1, so their degree is 1. Constant functions have a highest power of 0, so their degree is 0. And as you can see, here is an example of a quadratic written in standard polynomial form. And we haven't talked a lot about these, but we have worked with cubic functions, and cubic functions are also polynomials, and their highest power is 3, so the degree of a cubic function is 3. Now, there are also some other group of functions that intersect with linear and quadratic functions called power functions. And power functions are special because they only have one coefficient. As you can see here in the cubic function has 4 coefficients: a3, a2, a1, a0, or it could have, it has up to 4. Here, this particular cubic has 3 coefficients. This particular quadratic has 3 coefficients. This particular linear function has 2 coefficients. But in power functions, they only have 1 coefficient, and that coefficient is a number that cannot be 0. And the degree of a power function is, of course, the only power because it only has 1 coefficient, and that power is n. So if you were ever to graph power functions, there are 2 types of power functions: even power functions and odd power functions. And all even power functions look like parabolas. Doesn't matter if it's x squared, x to the 4th, x to the 6th, x to the 20th. If it's an even power, when you graph it, it's going to look like this. So as you can see, that these are all even functions. They're symmetric about a vertical line, in this case normally the y-axis, and their range is limited. It's not every single number because the numbers down here aren't a part of the range. So it's actually, the range is a restricted range. Whereas over here in odd power functions, like where the highest degree, well, the highest power is an odd number, or the degree is an odd number, like negative 12x, 5x to the third, 13.66x to the fifth. As you can see here, the range is every single number. The arrows indicate that it always goes up and it always goes down. So odd power functions are odd, but they're symmetric, about the origin. And their range is every single real number. So that's what we're going to do today. It's short and brief because you've already dealt with polynomials, and you actually have already dealt with power functions. You just didn't know it. Now we're defining it. A little bit later on in the week, we're going to be talking about special forms of polynomial functions besides just the general form as you see I've written here. Okay, see you later.